All right, we are on page 98. Is that right? How about questions about your homework? 35 and 36. 35, 36, 37. Okay, 35, 37. Okay. 35. Whoa. Finding tangents and normals. Find an equation for each tangent to the curve y equals 1 over x minus 1 that has a slope of -1. So slope is found by the differential. So to find the slope, I use the difference quotient. That's the limit as h goes to 0, right? So my thought process here is if I do the difference quotient of this equation, then I can set it equal to -1, solve it for x, and I'll find where the slope is -1. Does that make sense? Kind of like when we were looking for a horizontal tangent, we set it equal to 0. Instead of setting it equal to 0, I'm going to set it equal to -1. So let me show you what y'all are looking at me like, what the heck are you talking about? All right, difference quotient, which is the slope of the tan line, is the limit as h goes to 0 of f of x plus h minus f of x all over h. Have y'all got that memorized now? Have you written it down so many times that you remember it? All right, this time I'm not don't put -1 in for x, because -1 is not x, -1 is the slope. So what I'm doing is I'm going to say, when does this equal -1? Does that make sense? When is the slope -1? All right, so I have the limit as h goes to 0 of x plus h, 1 over x plus h minus 1 minus 1 over x minus 1 all over h. I need a common denominator. This is kind of gross, but essentially what I'm going to do is give each one the other one's denominator. So give this one an x minus 1, give this one an x plus h minus 1. And you can just put this whole bottom here in parentheses. All right, so I end up with the limit as h goes to 0 of x minus 1 minus all of this gobbledygook all over x minus 1 times x plus h minus 1. And I'm going to go ahead and say this is times 1 over h, just to get a complex fraction going. So -1 equals the limit as h goes to 0. Let's see what happens here. The x's cancel. This negative is going to distribute through, so the 1's are going to cancel. So I end up with -h over x minus 1, x plus h minus 1 times 1 over h. Now what happens? Cancel the h's out. That's exactly right. So the h's are going to cancel. So where does -1 equal? Now I have the limit as h goes to 0. -1 over x minus 1, x plus h minus 1. And now I can sub in. Y'all all okay there? Lots of variables, but they start canceling out nicely. If I sub the 0 in here, I end up with -1 over x minus 1 times x minus 1. I plugged a 0 in for that h. Oh, did we? Oh, okay. You just had to set it equal to -1. Oh, I see. Yeah, 21, we got a minus 1 squared. Negative a, 1 over a minus 1 squared. So now if I solve, I would cross multiply here, right? Negative x minus 1 squared equals -1 x minus 1 Y'all following me? What's that equal? I cross multiplied. So I could have x minus 1 equals 1 or x minus 1 equals negative 1. Square root of 1 is plus or minus 1. And because this was one of those rational functions, so it kind of looks like that reciprocal function. Remember, it looks like that. So there are potentially two places where that slope could be negative 1. So x equals 2 or x equals 0. Please let that be what they got. Yes. But it doesn't ask me just for the x values. It says find an equation for each tangent to the curve. Well, I've got the x value and I've got the slope. I need a slope and a point to write an equation of a line. I've only got half a point for each slope. So how do I find the other half of the point? Plug it in for x. So if x is 2, that means y is 1 over 2 minus 1, which is 1. And if x is 0, that means y is 1 over 0 minus 1, which is negative 1. So these 2 points, 2, 1, 0, negative 1. What was my slope again? Negative 1. That was given to me in the beginning. So I have 2 different equations that I'm writing for 2 different tan lines. Both of them have slopes of negative 1. Y minus 1 equals negative 1 times x minus 2. And y plus 1 equals negative 1 times x. X minus 0 is, of course, just x. Does that make sense? And that was just part A. That's just part A. But part B says find an equation for each normal to the curve that has a slope of 1. Well, if the tangent has a slope of negative 1, then at that same point is where the normal line has a slope of 1, right? Because it's negative reciprocal. So you've already found those points. Does that make sense? So part B is using these same points, but with a slope of 1. And that's it. And 37, is that what y'all said? Are y'all okay on that one? That one was tough. So part B says write an equation of the line, find an equation for each normal line that has a slope of 1. Well, if the normal line has a slope of 1, that means the tangent has the negative reciprocal of that. So you're really finding the same points. Essentially what you're doing, just different slope. Had I read that question, the parentheses that said see exercise 21 that we had done, like Henry said, we'd already gone through all this work and found, we had already found this. We just had to set it equal to negative 1. But that's okay. It doesn't hurt us to practice a little more. Yeah. Right. So the negative reciprocal of -1 would be +1. And then 37. I like 37. Y'all didn't like it? Aw. Okay. So I've got this function that's temperature as a function of dosage. 4/1 plus b. So your dosage, let's see. Find and interpret the sensitivity of the patient's temperature to the dosage 2 milligrams. So I'm looking at how the dosage of medicine per milligram impacts their temperature, because I'm looking at rate of change, and I'm looking for instantaneous rate of change. Is that not y'all's 37? That's not your 37. What's your 37 say? Oh no. Okay, it's probably the same concept, just a little bit different problem. So we're going to do IROC when D equals 2. Okay, and what is that giving us? That's rate of change, right? So my units for my rate of change are going to be, what's my Y? My Y is my what? Temperature, right? So it's going to be degrees, and what is my X value in? Dosages, which is, it gives it to me in milligrams. So I'm going to be looking for the degrees per milligram. In other words, for every, how does the temperature change for every milligram of medicine given? So it's really pretty cool because it's applicable, right? Say right, because it is. Okay, let's do, thank you, the limit as h goes to 0, and I'm doing T of h plus d minus T of d all over h. And if you didn't write it just that way, that's okay, but I'm doing it at a specific value, which makes it a little easier. I can plug those values in here. So now I want the limit as h goes to 0, 99 plus 4/1 plus, and now I plug in h plus 2. That's T of h plus 2. Do y'all see that? Minus, now T of 2, 4/1 plus 2. And everybody goes over h. Oh, I forgot the 99. Sorry. So this ends up being the limit as h goes to 0 of, and I'm going to split this up. I'm going to bring this h over here, multiplied by the reciprocal, just so it's a little easier to work with. 99 plus 4/1 plus h minus yep. All right, let's start canceling. Because I'm adding and subtracting here, I could really drop these parentheses, right? I could say 99 plus 4/3 plus h minus 99 minus 4/3, all times 1/h. You don't have to show that step, but I just want you to see why the 99s cancel. And now I have the limit as h goes to 0 of 4 over 3 plus h minus 4 over 3 I need a common denominator again. I'll give this one a 3. I'll give this one a 3 plus h. So now I have the limit as h goes to 0 of 12 minus 4 times 3 plus h all over 3 times 3 plus h. Starting to look a little bit better to me. I'm going to distribute that 4 through, so I have 12 minus 4h over 3 times 3 plus h. Don't lose track of your goal. Your goal is to get h out of the bottom. Okay, once that happens, or not, or try to make it where when you plug in, the box is not 0. At this point, my 12s are going to cancel. And now, because the 4h is the only thing left up top, I can cancel one of those h's. So now I have the limit as h goes to 0 of negative 4 over 3 times 3 plus h. And now I can sub in, which was what I wanted to do. So I get negative 4 over 9 degrees per milligram. In red? Here. Here. Okay, so I didn't combine that with the 99. Is that what you're asking? You sure? Right, right. What does this mean? Negative 4/9 degrees per milligram. At 2 milligrams. That's exactly right. At the point when they've received 2 milligrams, their temperature is declining 4/9 of a degree per milligram. Every milligram of medicine is causing them to drop 4/9 of a degree in their temperature. Does that make sense? But only at that instant, because that rate changes. The more milligrams, and the faster it probably drops their temperature. Okay. What else on your homework? 32. Y'all think this was the hardest section? No? Okay. The weekend. What was the weekend? But that was still this section, wasn't it? Like, do y'all think this is the hardest section in the chapter? It kind of brings everything together. The equation for free fall at the surface of Jupiter is S equals 11.44 t squared meters with t seconds. Imagine that a rock could be dropped from 500 meters above Jupiter's fluid surface. Find the velocity of the rock at t equals 2 seconds. All right, so if this is meters, what is velocity measured in? You know, meters per second, right? So velocity, and this assumes you know a little bit about this. If velocity is meters per second, then what am I looking for? You can probably guess with what we've been doing in this whole unit. IROC. This is rate of change, right? Rise over run. Meters per second. This is just in meters. This is going to meters per second. So what I really want is I want IROC when t equals 2. Isn't that what it asked me? Find the velocity of the rock at t equals 2 seconds. Yeah. The 500 is really irrelevant there. All right, so let's do it. That's the limit. As h goes to 0 of, we're going to do s of t plus h minus s of t all over h, but my t is 2. So that's the limit as h goes to 0 of 11.44. 11.44 2 plus h squared minus 11.44 2 squared all over h. Limit as h goes to 0. 11.44 times 4 plus 4h plus h squared minus, yeah, did I do something wrong? They're just saying it's measured in meters. S is measured in meters. Is that what you're saying? The M? Yeah, no, that's just the units. That is a little confusing, but that's just the units there. Right? Isn't that just the units? Yeah. Yeah, that's just your meters. Yeah. All right, minus 45.76 over h. Well, 11 times 4 is this number because I just did it, right? So that's going to cancel. And now I have the limit as h goes to 0 of, well, I know that it's 45.76 h plus 11.44 h squared. Everybody's over h. And now I can plug in. At 45.76, this is now 0 meters per second. When you have that equation there, that height that it's dropped from is completely irrelevant in this particular problem. Throwing in it. And they'll do that occasionally, especially on FRQs. They'll give you this vast amount of information in the beginning, and you have to disseminate what you need for each part, which is, I'm assuming, why they throw that in here in this so early on. You don't always use everything. What else? All right, well, let me give you a review. I'm going to let you get started on it. You got me for questions if you have them. It's going to look like a lot, but you got 2 whole class periods to work on it. And let's see. We're on page 101 to, I don't know what it goes to. Let's do 1 to 13 odd. If you need more practice with those, you can do those evens. If you don't, that's good. That's just a lot of the same kind of thing. I had written down what I wanted to Why did I jump to 26? I'm going to go, so 15 through 24, that looks like a lot, but those are all, you have a graph and you just state, yes, the limit exists, no, the limit doesn't. You don't even have to do justification. You're just looking at right and left, so those aren't hard. Let's see. Let's do 25. I'm sorry. If it starts taking a long time, we'll cut back some on it. But there's also three little AP practice problems I want you to do. They're 55, 56, and 57. But you got an hour today almost, and you got an hour and a half tomorrow, and I'll be here, so you should be able to get that done in 2.5 hours, I think, without even having to do it at home. Are y'all okay? Henry, don't look at me like that. You make me feel bad. Yeah. Yeah.